everyone, this is going to be a video about permutation testing. So to start, what is the difference between hypothesis testing and permutation testing? You'd perform a permutation test when you have two samples, but you don't have the population distribution and you want to determine whether or not those two samples came from that population. You would use a hypothesis test when you have a sample and you have the population and you want to determine if that sample comes from the population. To do this, for a permutation test, you would randomly permute the data and generate the null distribution under the assumption the null hypothesis is true, and you would compare your observed test statistic to the test statistics of the null distribution, and from there you would be able to determine whether or not to fail to reject the null hypothesis. Now, to go more in depth with this process for permutation testing, we have an example. So for example, we have a data set of Instacart orders and we have two samples. So the red histogram distribution represents the first sample, which is of Instacart orders of products from the produce department. The blue histogram represents a sample of Instacart orders from the frozen foods department. These two samples, as depicted by the histogram of prices, happen to look different. As you can tell, the mean price for the frozen food orders is around $57.818, and the mean price for the produce orders is $50.773. So the mean price for the frozen food orders is higher. Now with these differences, we have two possibilities. The first possibility is that the two distributions look different because they come from the same population distribution, and just by random chance, they happen to look different. So this would indicate that we have an unknown distribution of Instacart orders, which is our population distribution, and from that, we got our two samples, the produce sample and the frozen food sample. And the differences in the mean and the distribution is just because of random chance. The second possibility is that the two distributions are different because they come from different population distributions. This would mean that we have an unknown produce population distribution and an unknown frozen food population distribution. And our produce sample was taken from the produce population and the frozen food sample was taken from the frozen food population. From those two, we are able to create our null hypothesis and our alternative hypothesis. Our null hypothesis is possibility 1, that frozen foods and produce are not priced differently, and the two samples come from the same population distribution, but they happen to look different due to random chance. The alternative hypothesis is that produce is priced more expensive than frozen foods, and the two samples come from different population distributions, which is possibility 2. Now, we have a test statistic for our permutation test. We'll be using the difference in means. For this example, we will be using the mean price for the produce orders minus the mean price for the frozen food orders. The reverse also works, but for this example, we'll be doing produce minus frozen. So for our two samples, our test statistic would be 57.818 minus 50.773, which equals 7.05. So our observed test statistic is $7.05. Now, we don't know if this is a large difference or if it is a typical one under the null hypothesis. We don't know, and we can't tell just by looking at our samples. We need to see the distribution of the test statistic under the null hypothesis to see how common or rare it is. We don't have access to the entire population, so in order to determine, we must conduct a permutation test. The first step in conducting the permutation test would be to shuffle under the null hypothesis. So to shuffle the labels of the two groups under the null. The reason why we shuffle under the null is to generate the distribution of the test statistic under the assumption that the null hypothesis is true. That way we can compare our observed test statistic with this distribution and we can see whether our observation was rare under the null or if it was pretty common. If our observed test statistic was rare under the null hypothesis, this would indicate that it is very uncommon and we would reject the null hypothesis. On the other hand, if our observed test statistic was pretty common in the null distribution, we would fail to reject the null because this would indicate that it occurred frequently. Now we will have a live coding demonstration of how to code out and conduct the permutation test. This is the live coding demonstration for our permutation test, and we will be using the example Instacart orders dataset as we mentioned from the slides. So here is our data frame. It has two columns, prices and department. Each row represents an Instacart order, and the price column has the price of the order, and the department has whether or not the order was from frozen foods or for produce foods. So to start, I will be writing a function to calculate our test statistic. In this case, it is the difference in group means, where we subtract the mean price for produce orders minus the mean price for frozen food orders. As I mentioned previously, the opposite also works, but for this example, we will be doing produce minus frozen. So we have difference in group means. First, I will be calculating the group means by using group by, and we'll be grouping on the department column because during our permutation test, when we shuffle the labels, we will be reassigning it to the department column each time. So when we call this function, we'll just have to access the department column. We'll get the mean, and then we'll be getting the prices and return the difference of the produce mean price minus the frozen food mean price. And so here's our function, and as you can tell when we call it on our Instacart data frame, we'll get our observed test statistic. Which is around 7.05. First, in conducting our permutation test, we will be shuffling the labels of the department column. So this will be, this is how we shuffle under the null hypothesis because we want to generate the distribution under the assumption the null hypothesis is true. So we'll be shuffling the labels of frozen and produce using np.random.permutation. Now that we've shuffled the labels, we're going to assign it back into the data frame under the department column so that we can call our difference in group means function. Now we have our shuffled data frame, which is the Instacart data frame, but with the department labels shuffled. This is generating the two samples of the produce and frozen foods under the assumption the null hypothesis is true, and we'll be able to calculate a test statistic from this. And we're just repeatedly generating samples under the assumption the null hypothesis is true so that we can compare our observed later on. And now that we have our shuffled, we'll calculate the difference, our test statistic. And then we'll append this test statistic to our array of test statistics. So differences and now when we run this, we'll have an array of multiple test statistics under the null hypothesis. So these are all of our generated test statistics. So now we have generated our null distribution. We can go ahead and plot this on a histogram to see. So this is what our null distribution looks like of our simulated differences. We can go ahead and plot a line of where our observed differences to compare, to see in relation where the distribution is compared to our observed test statistic. And as you can see, our observed test statistic was around 7.05, and it is appears to be quite a lot higher than our null distribution. We can see from our plotted histogram and line where our observed test statistic is in relation to our null distribution, but we'll go ahead and calculate a p-value. So we will be counting the instances where differences, so the values from our null distribution, is greater than or equal to our observed. It is in this direction because our null hypothesis was that they are priced the same, and our alternative is that the produce is higher. So because we used our test statistic being the difference in group means of produce minus frozen, if the alternative was true, that would mean that the produce would always be higher, so the difference would always be positive. So we're looking to see when we have differences in our null distribution that are higher than what we observed, our observed difference. And from this, we see that our p-value is 0, so there were no instances from our generated null distribution where the simulated difference was greater than or equal to our observed difference. And so based on this, based on our permutation test, it is clear that it was not just by random chance that we got such a high difference, and that the possible reason could be that our two samples were from different population distributions. Now, just to briefly recap everything that we went over, we had two samples from our Instacart orders data set, and we noticed that they had differences in their distributions from the histograms and in their mean price. And from this, we were able to see that there were two possibilities, that they either came from the same population distribution and it was just by random chance that they appeared different and had different means, and the second possibility was that the two distributions were different because they came from different population distributions, and that was the reason behind why they looked different and why they had different mean prices. We were able to generate our null hypothesis and our alternative hypothesis, and we were using a test statistic of difference in means. We calculated our observed test statistic to be 7.05 because we were subtracting produce mean price minus frozen mean price. And we conducted our permutation test where we shuffled under the null hypothesis because we wanted to generate a distribution under the assumption the null hypothesis is true to compare our observed statistic to it. We coded out a function to calculate our test statistic and then coded out how to actually conduct the permutation test with shuffling the labels to generate the null distribution, and calculated numerous test statistics in each iteration to create a distribution of test statistics under the assumption the null hypothesis is true, and we were able to compare our observed test statistic with the distribution that we generated and a p-value, and we're able to determine that we reject the null hypothesis in this example. So that concludes this video. Thank you.